So are you guys real SportWit MCAT students?
Hell yeah!
Hi guys, so in this crash course in calculus, of course, the first topic I cover is limits. What I want to do here is give us an informal definition for limits, nothing super like technical or anything, just so we have a feel for what's going on, okay? So the idea is something like this. I'm going to do it in the context of functions. So let's say we have 1, 2, 3, 4, 5, something like this. Let's make up a function. Let's say f of x is equal to x, okay? Of course, if you think of this as y, that's the line x equal to y. Okay, no big deal. And then over here, let's just draw a line like that. Close enough. Okay. So if you're looking at 5, what we can do is we can look at 5 coming from the left-hand side. Okay? And we can also look at 5 coming from the right-hand side. So what I'm saying is, as we pick numbers closer and closer to 5, what happens to the height value? Okay? So if we were to say pick 4, we get something like this. 4 would give us 4. As we get closer to 5, let's say like 4.5. We get closer to a height value of 5. Does everybody agree? But now, if you come from the right-hand side, for numbers bigger than 5, you're going to get a height bigger than 5. But I think it's pretty believable, right? That as we get closer and closer to 5, this height value is also getting closer and closer to 5. So the way we're going to write that is the limit, right? As our x value approaches 5, gets really close to 5. For what function? For this function, y is equal to x. So our function, y is equal to x, right here, okay, is going to be what? Well, if you look at this picture, as the x values get close to the 5, the y values definitely get close to the 5. Okay? No big deal. Okay, so the limit of this function, so maybe I should write it like this. So as the x values get closer to 5, f of x represents the output values, the height. The height gets closer and closer to 5, and that is it. Okay? At this point, you might be wondering, like, why don't you just plug in 5 and be done with it, right? Okay, so we want to make a point about that. So in our first example, it's pretty mellow. But the thing to understand about limits is it's not what actually happens when you plug in a value, because sometimes you won't be able to. It's a matter of what the output value gets closer and closer to as the input value gets closer and closer to some number. Okay? And I'll show you what I mean just by modifying this. So let's just tweak this a little bit. So what I've done is I've tweaked this function so that you basically have the line y is equal to x except at the input value of 5. At the input value of 5, you don't end at a height of 5. You jump up here to whatever that is, okay? So let's pick some random number. Let's say, I know that's more than 7, but let's just pretend for the moment it is 7, okay? All right, so now the question is, what's the limit, right? Because if the idea was just you plug in the x value and see what the y value becomes, then the limit should be 7. Because when you plug in 5, you will get a height of 7, right? So that could be one way of defining the limit, but that's not how we do it because it's not useful, okay? So the useful way to do it is, okay, we don't care what actually happens at 5. We care what happens as you get really close to 5. Because what will happen in the future, or very soon, there'll be cases where you cannot actually plug in an input value. But you can get as close to that input value as you want and get useful information out of it. So that's what we're going to do here. So do you agree, though, that as we get closer and closer to 5, these height values, so I'm just going to try to draw it like this, but really I'm just worried about the height. Okay? These height values are getting closer and closer and closer to 5. Does everybody agree? And if from the right-hand side, the same thing. As you get closer and closer to 5, these height values are coming down. Let's pretend this guy keeps going, my bad. To 5, right? So as you get very close to 5, the output values get very close to 5. We don't care what actually happens when you plug in. We're just saying as you get very close, what's it look like? The idea is sort of like this intuitively. We want to know what this line wants to do. And it looks like it wants to converge to 5 when the input value is 5. Even though in actuality, when you plug in 5, you get some value up here, we don't care about that. What we care about is when you get very close to this guy, if this guy were nice and pretty, what would he be approaching? Okay? So that is the idea. Now that we have some idea intuitively what a limit's like, let's get some notation down. So what we said was, let's put this in general. If you want to look at the limit as the input values approach some guy, let's call it a, and you have to approach him from both sides to see if there's a true limit, okay? Then you look at the output values, which we can call f of x, and if these guys, as x gets closer and closer to a, if these output values get closer and closer to some number, right? In this case, it happened to be 5. Then we say that this guy's limit, we'll call it L, is that number. So in this case, the limit would be 5, okay? No big deal. All right, so now as long as we got this here, let's talk about some more notation. Notice I was saying that you get close to 5 as you come from the left, and you get close to 5 as you're coming from the right. Does everybody agree? Sometimes it's useful just to look at what happens when you come from one direction, because sometimes they don't agree, okay? I'm going to do an example of that in a second, but just to get the notation down, when you write, look at the limit as x approaches a, and let's say from the left-hand side, okay? Do you agree that whatever this value is, these guys on the left-hand side are less, right? So in that sense, think from the left or negative, because the values over here, if you go far enough, look negative. Okay? For this function, that just means that we care about the limit, but you only care about it when you're coming from one direction. In this case, from the left. But you could have equally well said, well, look at what it looks like when you come from the right. Does everybody agree? Okay, then we write it this way, the limit as x approaches a, but from the right is going to be positive, and the way to remember that is the values over here, if you went far enough, would be positive. Okay, so no big deal. All right, so let's actually put this into action and see a case where these guys wouldn't agree. Okay, let's look at this function, all right? So now we're just going to say here, so these 1, 2, 3, 4, 5, and again, 1, 2, 3, 4, and 5. Okay, the output value is apparently going to be 2 if x is what, less than or equal to 2, or less than 2. Does everybody agree? If the x value is less than 2, then the height value is always going to be 2. Okay, and it's going to be 5 if the x value is greater or equal to 2. So if you're at 2 or more, the height value is going to be 5. Okay, so what's the limit of this guy as you approach 2 from the left? So you know what to do. We're going to look at this picture and solve it graphically. Okay, so coming from the left, it looks like the height values are all 2. And as you get closer and closer to 2, these values are definitely just 2, 2, 2, 2. They're all stuck at 2. It doesn't matter what actually happens when you plug in 2. Do you agree when you plug in 2, you actually get a height value of 5? But that's not what I care about. I'm saying as we get closer and closer to 2 from the left, what do the height values seem to do? Well, they seem to be going 2, 2, 2, 2, 2, 2. So the actual limit here is 2. And you can see that. If you let this guy go on, he wants to be right here. Okay? Remember, that's not what he actually does. The actual value is right up here. That's where he wants to be. So I'm going to put the limits in yellow. Okay? All right, so now, all right, what about this guy then? What's the limit of the same guy as you approach 2 from the right? Again, the thinking is this. The height values are all 5. As you keep approaching 2, everything seems to be going 5, 5, 5, 5, 5, 5. So it looks like the value is right there, right? So the limit as you approach from the right, 5. It just so happens that the actual value when you plug in 2 is 5, but doesn't matter. That's not what determines the limit. What determines the limit is how you behave as you approach that number, not what happens when you actually get there. Again, you might at this point be thinking that's kind of silly, but there are going to be a lot of useful applications both in physics and engineering and all that sort of stuff. Okay, so let's start with this for the moment. But my bad, the most important question. Does the limit at 2 exist? Okay. And this is going to be nice. For a limit at a given point to exist, you need to have one number. But you can see as you come from the left, you're going to get what, 2? As you come from the right, you're going to have 5. Nobody can agree, right? So no limit exists as you approach 2. So here, it's basically undefined. Okay. And I know people tend to get stressed, but this is all there is to it. So if you understand intuitively what this stuff means, you've already gotten a good start. All right, let's get some rules of manipulation because we don't want to just try to guess stuff from pictures all day long, okay? On top of that, if you are looking at these different videos, this is definitely a GID video. If you're pushing through the compact course, which is basically the crash course, then you're definitely looking at the GID topics. If you look at the longer version of this course and you're more interested in this stuff, you should check out the MAD and the MAD videos.